All right, so dy dx equals negative x over y, and we're given some initial condition of y of 4 equals negative 3. Okay, so we can separate these things. So that would put me at y dy equals negative x dx. Now, the negative, it doesn't really matter where I put it. I can choose to put it with the y or choose to put it with the x. And sometimes there's reasons why one is better than the other. In this case, I made a decision, and there we go. So from here, I want to integrate both sides. Put that negative on the outside there. Okay, so that would be y squared over 2 equals negative x squared over 2, and then our constant at that point. Okay, so now we can evaluate using our point, and actually we can do a little bit of rewriting on this because we kind of have seen this general equation before. So if I multiply everybody by 2, so let's just do that. Let's take everybody on that side, multiply by 2, everybody on that side, multiply by 2. I get y squared equals negative x squared. Now that constant, that's one of my favorite concepts in math, is that constant just when you multiply by another number, you still get a constant. So I can leave it as c, because I haven't really changed the value of anything. It's just some unknown constant until I start plugging in parameters. And then I can bring the x squared over. So x squared plus y squared equals c, and that's the general equation for a circle. So we're looking at some kind of circle here. Okay, so now I can come in and evaluate that number, evaluate my initial information, and then I can actually solve for c. So that would say when x is 4 and when y is negative 3, what do I get for my constant? So that's 16 plus 9, so that's 25. Okay, so our general equation is x squared plus y squared equals 25. Yay! All right, so let's look at a slightly more complicated question. Now, initially, we might not see that it is separable. Our initial goal is to just try to algebraically move things around so that y is on the one side and x is on the other. And we might not be fully convinced when we first look at it until we start thinking about algebraic properties and rules and stuff that allow us to manipulate that. So, for example, the e 2y minus y, that's a function in terms of y, so that's okay. It's on the left side. And I see an e to the y over here, and I want to move it to the left. Well, if I'm multiplying by e to the y on the right, I want to divide by e to the y. So that means on the left side I have e to the 2y minus y over e to the y. And that's dy. Okay, now if I, similarly with that cosine right there, cosine of x, that needs to move over. So I'm going to take sine of 2x and I'm going to divide it by cosine of x. Okay, so now I've got it, so clearly it's separable, and I kind of do a little bit more algebraic manipulation. So I notice, for example, sine of 2x has an identity where potentially I could divide the cosine out. So sine of 2x is 2 sine x cosine x. So that'll make my life a little bit easier here in a second. And additionally, I see the e terms that can simplify as well. So I can take e to the 2y over e to the y minus y over e to the y. Still put that in terms of dy. And let's do a little clean that up. So e to the 2y divided by e to the y. E to the 2y is e to the y times e to the y. Divide out one of those e to the y, so I'm left with e to the y. And I'm going to go ahead and bring that, in the other fraction, y over e to the y, I'm going to bring that up as a negative exponent. So minus y of e to the negative y dy. And then the cosines I'm going to divide out, so 2 sine x dx. Okay, and now I'm in a position where I can just do some good old-fashioned integration. So e to the y minus y, e to the negative y, and we'll put the 2 on the outside there, sine x dx. Okay, and let's see, e to the y, that's pretty boring. That's just e to the y. This other one, right, that's that illustration of U-substitution. So let's kind of think about that. So let's, so minus integral of y e to the negative y dy. So I'm just going to hang out here for just a second. And in that case, give myself a little bit more room here. I want u to equal negative y. And so what would du equal? That would be negative 1 dy. So let's see. So I want to bring that negative in. All right, so that's plus the integral of e u dy. I'm thinking too simplistically about this because this is just a u sub. I think this is integration by parts one. Okay, so U-substitution didn't work out so well for us, but it was a nice try. So we want to go with integration by parts would be the next approach I want to try. So let me come back up here. And if I do integration by parts, so I want to put a y here and a negative e to the y there. And I'm going to differentiate this direction, and I'm going to integrate this direction. So that'll give me a 1 there, and that'll give me a negative e to the y. And then I want to focus on the diagonal component for that. So I give myself a little bit more space. Okay, so this e to the y I'm dropping down, so I'm going to drop it down again. So e to the y, and then it's minus, and then I have negative y e to the y plus the integral of e to the negative y dy. And that one works out nice and pretty. So I should end up with e to the y plus y e to the y. Maybe a little bit careful about my notation there, e to the y, plus e to the negative y. Okay, so that's all on the left side. So what's going on the right side? So on the right side, all the way, well, barely on the screen there. So I'm going to carry this down a little bit. So we have 2 integral of sine x dx. That's a pretty straightforward integral there. So that'd be negative 2 cosine x, and then we have our plus c. So let's put all of this together. So we got e to the y plus y e to the y plus e to the negative y equals negative 2 cosine x plus c. Okay, so our general equation looked like that. Were we given any initial conditions? Let's see. Yeah, so we were told y of 0 equals 0. So we can do some good old-fashioned evaluating. So That gives me e to the 0 plus 0 times e to the 0 plus e to the negative 0 equals negative 2 cosine of 0 plus c. All right, so what is all of that? Well, this middle thing right here, 0 times e to the 0, that's just 0. And e to the 0 is going to give me 1. And e to the negative 0 is going to give me 1. And so we got negative 2 here. And then cosine of 0. Cosine of 0 is also 1 plus c. So I get 2 equals negative 2 plus c, so that means c has to be 4. Okay, so our general solution then would be e to the y plus y, e to the y plus e to the negative y equals 4 minus 2 cosine x.